So I'd like to start out now by introducing our first speaker, Nicole Molinari. She's right there at the computer. She is the United States Forest Service Southern Province Ecologist. She has a broad interest in the consequences of human-induced global changes, including the effects of biological invasion, nutrient enrichment, climate change, and altered disturbance regimes on vegetation patterns. She received a PhD in ecology and evolution from UC Santa Barbara. She is particularly interested in questions that would couple her curiosity for the natural world with applied outcomes that can inform management and land use decisions. Nicole is a Southern Californian and lives in Goleta with her husband, 2 young boys, and dog. She is stationed on the Los Padres National Forest. Nicole will speak on climate change and the future of the California wild forest. Nicole?
Thank you, George. Good morning, everyone, and thank you for inviting me here today to talk to you about global changes in forest health. And you'll notice that much of the talk will focus on climate change, but there are multiple global changes that are affecting forests and vegetation throughout California. And so I will be talking about some other topics like non-native species, as well as altered disturbance regimes, which is probably something that most of us don't think about too often. I actually think of it on a daily basis. We're going to get into some of the nuts and bolts about how our forests and our landscapes have changed. So before we dive into forests, I just wanted to tell you a little bit about where I work and the kinds of things that I do. So as George said, I'm a scientist or an ecologist for the Forest Service, and I provide the best available science to management decision making for national forest lands. And so I am the ecologist for these 4 forests. So it's 4 million acres. I'm stationed on the Los Padres, which is headquartered in Santa Barbara. And the Los Padres starts up in Big Sur, that little yellow nub that you see at the top of the screen, and goes all the way down through Ventura and Ojai, where it meets up with the Angeles, which provides the wonderful backdrop for Pasadena. Just to the east of the Angeles is the San Bernardino National Forest, and the San Bernardino has 2 pieces to it. One bear, and then the other is Idlewild, so some of you may have spent some time there. And then lastly, the Cleveland Forest is the green at the bottom of the screen, and it largely is in San Diego County and nearly abuts the border with Mexico. So in these 4 million acres, I do have to say that largely these are shrub-dominated landscapes. So very different than what I'm going to be talking about today. I'm going to be talking about forests, places with trees. Our forests, these 4 million acres, about 75% are dominated by chaparral and coastal sage scrub. And about 10% has forests. And so while I'm going to be talking largely about the Sierra Nevada, the principles and ideas that I propose translate to our forests here in Southern California as well. Okay, so in the news, all the major news sources over the past year have been covering the massive amounts of die-off that we've been experiencing within California. So the current estimates are that we have 102 million dead trees within our state. So let's take a closer look at those numbers. This is a graph that was generated by the U.S. Forest Service, and I'll tell you how in just a moment because I think it's somewhat interesting. But on the y-axis, in case you can't see that, I can't really see it. Let's see, it's number of dead trees, and on the x-axis we have time. So that first orange bar, or the orange bars in general, are the number of dead trees that were counted during that year. And the white line is the cumulative sum of those trees dying on the landscape. So in 2014, that's where you see the first orange bar, we had 11 million dead trees, and nobody was really paying much attention at that point. People were pretty comfortable with that number. 1 year later, we had 40 million dead trees on the landscape. People started to notice, so that's a quadrupling in 1 year. And today, 2016, we don't have our estimates from 2017 yet, there's 102 million dead trees on the landscape. And now this has really caught the eye of everyone in the state. And I'll talk a little bit about how Governor Jerry Brown has been responding to this later in the talk. So the way that we know how many dead trees there are, we could use satellite imagery to look for changes in greenness through time, but rather to get an actual count of the number of dead trees, the Forest Service sends biologists, botanists, ecologists up in Cessnas with tablets, mapping tablets, and we fly along flight paths and map out areas of forest death. And so we can get at what species are dying. We can start to get at the proximate cause of that death. So is it bark beetle death? Do we know what kind of bark beetle it may be? And so that's how these data are generated. I just want to point out that in California, it's estimated that we have over 4 billion trees. So some people say, well, you know, what's 100 million dead trees? It's a drop in the bucket. But those trees are concentrated in on the landscape where they're dying, and I'll show you a map of that. And so maybe if there was dead trees kind of punctuating California here and there, it wouldn't be such a big deal, but because these dead trees are concentrated in the Southern Sierra and in these lower elevational bands, it's a true ecological disaster and a huge fire risk. I want to mention that while I'm going to be talking about bark beetles and conifer trees, that all trees outside of urban and agricultural environments are included in these estimates. So oak trees, any riparian trees like sycamores or alders or aspen would also be included in these numbers. Okay, so here's a map of mortality from 2016 across our state. And you can see that right here, and this is the southern to central Sierra Nevada, we have the massive amounts of mortality happening. But I don't want that to distract from my Southern California forest, where we also have mortality happening. In some cases, it is from bark beetle attack, but there are other pathogens and insect pests on the landscape that are wreaking havoc. And some of these are non-native. The gold-spotted oak borer is wiping out coast live oak and other species of oaks in San Diego County. And it's being moved in firewood. So it's non-native to California. People are cutting down dead oaks and moving that around. So I have a dead oak on my property in San Diego, chop it up. I'm gonna go camping with my family in Santa Barbara. I'm gonna bring that wood with me, and it's infested with the gold-spotted oak borer. So that's the way that these insect pests are, some of them are able to move across the landscape. Shot-hole borer, which Linda is gonna touch on, is gonna have some serious problems probably for urban environments as well as agriculture. It's a pest on avocados, which has gotten a lot of people up in arms. And then in the Big Sur area, so right up in here, which is part of the Los Padres, we have something called sudden oak death. And this was a pathogen that was brought in from horticultural stock. It's thought that it came in on azaleas from Monrovia Nursery. People put that in their yard, and the spores were able to spread into the wildlands, and it's killing tan oaks and other live oaks in Big Sur. And so the real focus of the talk is going to be on the massive mortality that's being caused from bark beetles in the Sierra. So here's a photo for those of you who haven't seen this. It's quite stunning. The inset photo here is a picture, this is from Fresno County in May of 2015. And when you look at this picture, you can see, just for reference, this little white spot here is the roof of this house. So you can kind of see the similarity between the pictures. There's a few dead conifer trees in May 2015, but in February 2016, not even a year later, I would say there's over 75% mortality within this stand of conifers. So this gives you an idea of the pace and scale at which we're seeing bark beetles attack and cause death within these forests. Okay, so that's a little bit of background. We now know that we have these 102 million trees. We're sitting right about here. I've split the talk into two parts. How did we get here? What are the things and the stressors that allowed the environment to not be resilient to this? And once we go over this part, and I think there's some lessons we can learn here by going back in history and thinking about how we got to this point in time, we'll move on to what does the future hold? And can we take any of the principles that we learned here and apply them over here? I hope so. So how did we get here? Well, it's not a simple answer. If it was a simple answer, I probably wouldn't be here talking to you about it today. There's multiple stressors in the environment that are causing this massive conifer mortality. And those stressors are fire suppression, drought and climate, and our friends, the bark beetles. So I'm going to go through each of these stressors and talk about the state of them, but also talk about how they interact with one another. And some people actually consider these stressors to be working synergistically. So one affects the other, and all of that comes together to kill the conifer trees. The true proximate cause of death is the bark beetles, but the bark beetles wouldn't be able to get a hold if these things, these kind of anthropogenic cause factors, weren't out of whack. Okay, so starting off with fire suppression, we're going to go back a couple hundred years and think about before Europeans arrived on the landscape, what did conifer forests look like? Well, I can tell you that there was a whole lot of ignitions, fire ignitions in conifer forests, both from lightning, and we still have that today, but also from Native Americans. So Native Americans were lighting conifer forests on fire to maintain grasslands and meadows for food sources, as well as for medicinal purposes. It also improved deer browse and enhanced production of basketry materials and reduced fuels. So there was a lot of fire in these systems. Fire was very, very frequent. And because of that, the forest structure, or the stands of conifer trees, looks something like this. And so when I say forest structure, what I mean, and what you should be looking at when you look at this picture, is the architecture of trees. How far apart are they spaced? Is there a lot of vegetation between the ground and the top of that tree, or is it pretty open? When I look at this stand of conifer trees, I think that this is a really open stand. So the overstory trees, the big trees in the picture, these big guys here, are sparse and scattered. There's a decent distance between one tree, so probably not a whole lot of competition between individuals. And there's very little understory vegetation. So you don't see that there's a bunch of shrubs and little trees and things growing in this understory. So you can imagine that fire has played an important role. Fire is very frequent in these systems hundreds of years ago. It plays an important role in cleaning out that understory. And when that happens, fire burns at a very low severity. You have an ignition, and that fire can just burn along the surface. I'll show you some pictures of that in just a moment. This fire regime started to change. And it started to change when Native Americans were prohibited from burning because fire was threatening agriculture, ranching, mining, little communities that were popping up throughout the West. And so in the 1790s, there was burning was completely prohibited by the Spanish governor. And around that same time, Native Americans were pulled off the landscapes and put into missions. And so we effectively had Native American burning practices being eliminated for the most part. This event, coupled with forest reserves, which would later become U.S. Forest Service land, they were established around the same time, and they were established to reduce the risk to timber. The western United States had a very rich resource of lumber. And so people who had established themselves in the West were what the president at that time was considering recklessly harvesting. They were just going out and harvesting everything, and there wasn't any regulation. It wasn't federal land. And so the forest reserves were established to try to slow that harvest down and to put some regulation on it, but also to try to keep fire out of these systems, because when fire would burn through the systems, there was the potential for us to lose that economic value from the timber. In 1910, there was a huge fire in Washington, Idaho, and Montana called the Big Burn. There's a book that's been written about it, which I think is fascinating. This fire burned almost 3 million acres, killed nearly 100 people, devastated little mining communities and lumber mills that had established in this part of the United States. And at that time, Congress said, whoa, we have got to stop this. Fire is totally out of control. There was a number of policies that went into place, and the 10 a.m. policy is an example of this, where they said no more fire. We have got to learn to suppress fires and to do it well. And so the 10 a.m. policy is a policy that basically said, if a fire gets started one day, we want it out by 10 a.m. the next day. So, people rose to the occasion. Of course, you're probably thinking down here about Santa Ana wind events. Now, take Santa Ana winds out of the equation, because in these conifer forests, especially in the Sierra Nevada, we do not have Santa Ana winds. So fire suppression is quite effective. We also, during the World War II era, had air operations for firefighting enter into the scene. So now we have smoke jumpers, we have the ability to use helicopters and planes for retardant and water drops, and we got really good. We in the West are pretty much still considered the premier firefighting groups in the world. We can do it really, really well. And unfortunately for conifer forests, a little too well. So fire suppression becomes widespread and highly effective. So what happens to these forests? We used to have these open stands. Remember this picture? This is when we had frequent fire, low severity fires. We now have stands that look more like this. And so some of the things I want you to notice is that the trees are much closer together, the large trees. There's a dense understory vegetation. So we have shrubs here, and then we have medium-sized trees. When fire gets into a dense conifer stand like this, do you think it's going to be low severity anymore? No, that fire can start down here, and it can jump up to the shrubs, it can jump up to these little small trees, and it can jump into the crowns of the trees and cause crown fires. So one of the things you may have heard people talking about is that fire severity is getting worse, and we're having stand replacing fires in our landscapes today. And this is one of the reasons, because our forests have a different structure. They're much more dense. So what I'm saying here is that we've had a change in stand structure from fire suppression. And when we think about how that affects fire in the landscape, we go from a situation like this, which would be a ground fire, which would remove a lot of the smaller trees and shrub individuals, to a fire where the fire can get up into the crowns and completely kill the trees. Now, I know this is not a story. I'm talking to you today about bark beetle mortality. This is not a story about fire, but when we look back at this stand, think about how competition for resources like water has changed. So here I said, well, gosh, these trees are pretty far apart. They probably weren't competing so much for water. Now when you look at a stand like this, there's a lot of competition for resources, light, water, all kinds of things. So drought stress is much more likely to happen and be intensified in these dense forests. Okay, and I would say that probably 75% of the forested land in Southern California and in the Sierra Nevada hasn't burned in maybe 75 years, a long time. So this stand structure is what we're seeing broadly across the landscape. Okay, so enter in drought. We have dense forests. Now we have drought, extreme drought, one of the most intense droughts that we've ever had, and most certainly the most intense drought that we've had in our written record. So it starts in around 2012. These are data compiled by the US Drought Monitor, and they've created an index of drought where this light yellow color is abnormally dry, but you see that intensifying. And in 2015, this deep red is basically as droughty as they've ever measured, and that's exceptional drought. That continues into 2016, where over half of the state is in this exceptional drought category. Here we are today. We had a lot of rainfall. People are saying, the drought is over. We are good to go. The trees are gonna, come back. No big deal. We'll talk a little bit about this later when we talk about the future and what I foresee happening to these forests in the future and whether or not that's a valid argument. Okay, so we have drought on the landscape, and we have native bark beetles on the landscape. So these bark beetles are native. There's multiple species. I put 3 species up here because these are the primary tree killers for conifer trees. And there's the western pine beetle, the mountain pine beetle, the Jeffrey pine beetle, and many others. They all kind of look the same. They all have a similar life cycle. So I'm going to talk about them generally for the rest of today. So these are native species, and typically they stay at very, very low population levels because they can only attack and kill unhealthy trees. So an example of this is the way that the beetles interface with the trees. They come up to a tree, they fly, they come up to a tree, they bore in through the bark, and once they start boring in through the bark, a healthy tree can pitch that beetle out. So a healthy tree has resin production, it has chemical defense for herbivores, and it can literally push that beetle back out of that hole that it bored. And so right here where you see unsuccessful attack, this is where the beetle bored into the tree, and this white stuff is all the pitch. The tree said, I'm healthy, I'm gonna push you right out. And so that's what happened. You can see the little beetle was stuck in the resin and died there. So if you don't have dense forests, if you don't have drought stress trees, this is what we would expect. So you could imagine that beetle populations were pretty low in California forests for a long, long time. But now that we have these very stressed trees, we have successful attacks. So that means that the beetle bores in to the tree, and the tree does not have enough fluids in it. It does not have the capability of producing resin, and it can't pitch that beetle out. So the beetle comes in and does its thing. So here is its thing. Okay. So this is our bark beetle. And here is that borehole that I was talking about. That bark beetle bores in, and it reproduces, lays its eggs, and it forms a gallery on this inner tissue of the tree. And so this inner tissue is the sugar conducting tissue. We call it the phloem. So you have your bark, and then if you were to peel away your bark, the next layer in a tree that you'd come to is the phloem, and it's the way that the sugars move up and down through the tree. And the sugar's the food, so it's really important that sugars are moving up and down in a tree. And if you have a larval gallery that has formed, that breaks and cuts across all of those sugar conducting cells. Sugar can't move anymore. So this is one way in which the bark beetle kills the tree. But you notice that there's not just one borehole here. There's a whole lot of boreholes. So when a bark beetle is able to get into a tree and be successful, it releases an aggregating pheromone. So it's like a volatile compound out into the environment saying, hey guys, I got into one, come on over. And all of the bark beetles come. There's evidence of 25,000 bark beetles that will swarm a single tree, just to give you an idea. So all of these boreholes that you see, you could imagine these galleries being created all throughout that tree. Mortality is gonna happen relatively quickly, and it will definitely happen. The last thing that this beetle does before it takes off and flies for another tree is when it begins feeding, so it's kind of interesting, the parent feeds in this vertical direction, and all the larvae, so there's little maggot-looking larvae at the end of each of these boreholes. So there's the parent's feeding gallery, and then the babies are out feeding in a horizontal fashion. But the parent, on its mouth parts, has this a fungus. And the fungus has a blue hue, and so as you look to the top of this tree, you see all this blue material here. You also see it in this cross-section of this log that I put up here. So that fungus from the beetle's mouth goes into the inner parts of the tree. The inner parts of the tree is where water goes up and down the tree. So we already talked about sugar moving up and down. This inner part is called the xylem, right here, and this is where the water moves up and down. And so the fungus grows across this woody xylem material and plugs up all of the straws that allows the water to flow. So there's a double whammy here. The tree really doesn't have much defense. And I think that this is important to point out and just to talk about the blue fungus for just a second, because when we talk about where do we go from here, one of the topics is, what do we do with all these dead trees? 102 million dead trees, what are we going to do with them? And people say, oh, the lumber companies are going to go bonkers. They're going to be thrilled. Well, guess what? Our bark beetle trees are undesirable. They have a very low value because people aren't really interested in a gray-blue wood. So we'll return to that topic in just a little bit, but I wanted to point it out now. But the other point is that this life cycle, now there's a new figure up here, this life cycle that the bark beetle undergoes, lands at the tree, bores in, lays its eggs. This is a baby bark beetle. That bark beetle pupates and is able to fly off to another tree and work its magic. So this cycle, in cooler conditions, in colder places, may take 2 years to complete. So it's really slow. In warmer places, this cycle can happen in a single growing season. So when you think about global warming and warming temperatures and how that could facilitate and help the population numbers of bark beetles, we could be entering into an era as it gets warmer and warmer where the growing season's longer, the growing season's longer, and maybe these bark beetles will be able to do 2 generations within a single growing season rather than a half of one or one. So this is something that scientists are concerned about right now, is that this could potentially cause exponential beetle growth, which would really increase the pace and scale with which beetles can kill trees. Okay, so here's a couple of pictures from the Southern Sierra, and you can see that the mortality is widespread. Another interesting point, though, is you can also see that there is some host specificity for those beetles. So in this particular conifer stand, there's only one species of tree that is dying, and that's the sugar pine. And the other conifers, you can see them in here, and they look just fine. So in some cases, we see mass mortality. All the trees are dead on the landscape. In other situations, we see that some of the conifers are able to persist. And this, to me, gives me much hope for the future. And we'll talk about that a little bit more later. Okay, so how did we get here? It was a story that involved fire suppression, forest densification, the onset of drought in 2012, and then bark beetles capitalizing on that drought. So what does the future hold? Where do we go from here? And I think there's really two interesting pieces to this. One is the immediate response. What do we do now with this 102 million dead trees? What's a strategy for dealing with them? And then the long-term prognosis. Do we expect this to continue to happen into the future? We just had a wet year. Are we in the clear? Is it possible to create resilient landscapes? So we will start with this the top question. What's our immediate response? Well, from an impact standpoint, in 2016, 7,500 miles of National Forest Service roads have been impacted, and you can see a picture of that right here. And that doesn't mean that there's trees down on the road and people can't drive. What it means is that there's dead trees lining those roads, and that creates a serious risk for the public. There's 2,300 miles of trails. Those are hiking trails and mountain bike trails. 340 miles of power lines. This is a big one because we've already experienced on the Los Padres forest, we had an oak tree that had been weakened from an insect pest and drought, and one of the limbs fell on a power line in one of our campgrounds, started a fire, which ended up being 35,000 acres. Luckily, nobody was hurt and we didn't lose any homes, but this is a serious concern. 340 miles of power lines with dead trees around them is really dangerous, right? A huge fire risk. 485 recreation sites, so these are largely campgrounds. 140 communities in close proximity to Forest Service and just other lands that have been affected by bark beetles. And so those are all from a human perspective. You know, that hasn't even touched on the way in which this mortality will affect wildlife or will influence fuel loading and could change fire risk. But at this point, our focus, and when I say our, I'm talking about pretty much all the land management agencies in the state, are focused on hazard tree removal. And so there has been a lot of money already sunk into starting to remove trees along the sides of roads, remove trees away from power lines, away from campsites, because we as land managers, our primary goal is recreation. We want people to come and enjoy the forest. We can't lead them into death traps. Come visit, come camp with us, you know, and there's dead trees all over the landscape. So we have been focusing on hazard tree removal, and you can see some of the statistics here from 2016. Forest Service has put $43 million towards this cause. CAL FIRE, which is the fire agency for state and private lands, has put in 80,000 staff hours and a little over $10 million. Caltrans, $56 million. They're trying to clear those roads, and in the next couple of years, it's thought that amount could double. And I couldn't find any information about the utility companies, but you better believe they are out there trying to clear those lines, because from a legal standpoint, if a fire starts on the forest or on public lands from a power line, there tends to be litigation. And so they want to make sure that that is unlikely to happen moving forward. Jerry Brown has also put together a tree mortality task force that's made up of state and federal groups. All sorts of stakeholders are part of this task force, and there's different working groups. I put the 8 working groups up here so you can see some of the major foci that people are trying to work towards finding solutions. Part of this tree mortality task force is this really, really cool tool, this mapping tool, where you can put on bark beetle mortality, you can overlay roads. In this particular case, I've overlaid bioenergy plants. So you see that I've highlighted here that 2 of the working groups are focusing on utilization and what do we do with all of this material. One of these groups is solely focused on bioenergy. Can we use this for bioenergy? What does that look like? How would we get the material to bioenergy plants? And then the other one is focused on market development. So if we start here, there is some lumber interest, so timber companies are interested in some of the wood, but many places, especially in Southern California, we don't have any mills here. And so when you think about the San Bernardino National Forest and the Big Bear area clearing out these dead trees, people from Northern California aren't going to truck down here to grab blue stained wood that has very low value and truck it all the way back to their mill. So we're having a really hard time getting getting timber companies to be interested in this material. One of the things that we have had success with was bioenergy. So essentially this is taking the wood and burning that wood for energy. There's a couple of issues with bioenergy. There are bioenergy plants that have popped up all over in the Central Valley, or maybe they popped up quite a few years ago. These dots all indicate bioenergy plants, and they were built in the Central Valley to burn leftover agricultural waste. Many of them have closed because solar power and wind power are so much more economical and environmentally friendly. So with bioenergy, all of that burned material, all of the carbon that used to be in the trees is now being released as carbon dioxide and contributing to global warming. So we're trying to kind of shy away a little bit from that, but it is one way that we are processing this material. The other, and this is still part of the market development, is the creation of biochar. And so there's these little biochar machines that can be pulled behind trucks, and essentially you can put wood into these machines, and the wood is burned at very, very high temperatures in the absence of oxygen, and so you get these kind of charcoal briquette looking structures which can be broken up and used as soil amendments. And so people are quite pleased with the outcome of biochar because there's very little carbon released to the atmosphere, and the carbon is stored in that charcoal as a pretty stable compound. And so it would be a great way to continue to keep carbon storage on the landscape and not releasing it to promote global warming. Okay, so the long-term prognosis. So that's a little bit about our short-term response. What are we expecting, and what kinds of things can we do to combat this issue? So if we go back to this schematic that I put together, well, some people say, well, why don't we get rid of the bark beetles? And as an ecologist, I'm like, no, these bark beetles belong here. The bark beetles are responding to some of the problems that we've created with drought and fire suppression. So the bark beetles are native bark beetles. That people do put forward, maybe we can use some pesticides to keep bark beetle numbers at bay. I would not advocate for that. I would say let's truly clean up the mess, and bark beetles will respond appropriately. If there are not as many drought-stressed trees on the landscape, the bark beetle populations will stay pretty low. In terms of drought, well, 2017 and the rainfall that we've received this year has got a lot of people thinking, hey, we're in the clear, so do we really need to be concerned about drought? Was the last 5 or 6 years maybe just a fluke? Well, let's take a look at some of the climate modeling for California. This is busy, but we'll go through this together. There are many, about 25, each of those little dots on that graph there represents a global circulation model. So there's climatologists all over the world that are trying to put together the most accurate model to predict how climate's going to change in the next 100 years. And all of them have a slightly different model that they've put together, slightly different algorithm. They use this parameter, that parameter. And so what you see here, the scattering of all these different colored points, are different climate models and people trying to project what's going to happen over the next 100 years. So, okay, what do they say? So on these axes, on the bottom, the x-axis, this is projected temperature from current to the future. So if the climate model for California is predicting that it's going to get hotter, we would expect this number to be positive. So here's the 0 line. All of the climate models from across the globe are saying, yes, here in California, it is getting hotter. The magnitude of the increase in temperature depends on the model. So some people think it's not getting that much hotter, while other people think it's going to get a whole lot hotter. And so we don't quite know where that stands. There's a lot of uncertainty here. And this little dot right here in the middle is the average of all of these climate models brought together. So people think, well, this is probably the most conservative or reasonable estimate. Let's take all the models from all these different groups and average them together. And that is what is seen right here by the ensemble mean of all of them. Okay, so we're feeling pretty confident that it's going to get hotter. What is the deal with precipitation? A little bit more complicated. Oh, before I move to precipitation, what does a warmer future mean for bark beetle mortality? Well, with warmer temperatures, precipitation, regardless if it goes up or down, will, in high elevation areas where conifers live, will be more likely to fall as rain rather than snow. So we're expecting to see snowpack decline in parts of the Sierra and in Big Bear, let's say, so high elevation places. As snowpack declines, think about how the trees interface with water throughout the growing season. If there's a lot of snowpack, that snowpack slowly melts in the spring and summer and provides available water to the vegetation. If all of the water falls as rain, there's no long-term resource for the vegetation to get through the hot, dry summers. So the trees are going to be much more stressed if if precipitation is falling as rain rather than snow. Also, in hotter temperatures, there's an increased plant demand for water. And we already talked a little bit about how bark beetle numbers could potentially go up with hotter climates. So they could undergo that life cycle, maybe 2 life cycles within a growing season rather than 1. Okay, so now we can move on to precipitation. This y-axis is the change in precipitation from current looking to the end of the century. And you can see that this blue line that I've put on the graph indicates more water, more rainfall on the landscape. And you can see that almost half of these climate projections are saying, California is getting warmer, or getting wetter, excuse me. California is going to be warmer and wetter in the future. So it's sort of like, whoa, okay. And then the other half of the climate projections are saying, or climate models are saying, no, we're going to get drier, so hotter, drier. So where do we go, What exactly is happening here? Well, I think that it's important to understand that these projections are very coarse. They're averages for the entire state of California. What happens if we dig in a little bit deeper and look at that climate projection on the landscape? So I've done that for you. So these are California averages. We know California's a big, long state. There's a lot of variation in our state. Let's take a look at these 3 climate scenarios mapped out for the state. So I chose a warmer, wetter future, the average that I talked about of all the climate models, and a warmer, drier scenario. Okay, so here we go. So here is the warmer, wetter scenario. And you'll notice here on the scale bar that in these areas of red, so much of Southern California and the Central and Southern Sierra are, despite this being a warmer, wetter future, are still going to experience drying under this climate model. The ensemble mean, same thing. We have the magnitude. It's going to get much drier in Southern and Central California. So a difference from current to end of the century of 19 millimeters. And then in the warmer, hotter, we see that really ramps up, and it's predicted that we'll have a decline in rainfall or precipitation of about 38, I think that says, millimeters. So there are areas that are projected to get wetter, but here in Southern California and the Central and Southern Sierra, we expect there to be drying despite the climate model and how it's averaged across the state. So the drought conditions will continue to favor beetle mortality. So in my mind, I don't expect this wet year that we had to end the mortality that we're seeing, and I do think that it will continue into the future. Okay, so lastly, and this I think is maybe the most hopeful story in my mind, is there a way that we can turn back the clocks, or that we can change the density in these forests? Getting rid of fire suppression, that I don't think is gonna fly, but maybe there's some other things we can do. Okay, so as I suggested earlier, we've gone from this open forest structure to this very dense forest structure where the trees are very, very stressed. Is it possible to restore these dense forests back to the pre-European stand structure? Could we do that? And that could provide the opportunity for these forests to be more resilient to drier conditions, because the competition would be much lower. Those trees are much further spaced apart. So we would have a reduction in resource competition and potentially a reduction in drought stress. So how do we do this? So this is a figure that was put out by Oregon State on forest thinning. And so we are, not all of our landscapes, but much of our forested landscape is up here in this very dense architecture. So there's a lot of trees in there. And so one thing that could happen is we could thin. So this is a figure showing light thinning. You notice some of the smaller diameter trees, some of the shorter trees are removed from the landscape. In some cases, you could take that to moderate thinning, and in other cases, you could take it to heavy thinning. And under these conditions, we might be able to reintroduce prescribed fire back into the landscape. So if we took our current day forest that's very dense and lit a match and tried to say, we're going back to frequent fire regime, everyone, what would happen to that forest? It would blow up in a high severity fire. So we cannot just put fire back on the landscape. There needs to be this intermediate step that we take that includes thinning out some of the forest. Now, as you can imagine, there has been a decent amount of public pushback when people think of going into the forest with chainsaws and removing trees. There's a lot of discomfort associated with that. People are saying, well, that's been what my backyard has looked like for the last 40 years. That trail that I used to hike since I was 5 years old, it's always looked like this. And so there's been a shifting baselines people are used to, and they really like these dense forests. But from a long-term vision, I don't think that these dense forests, they're not going to be resilient to some of the global changes that we are seeing and that we're going to continue to see into the future. So something needs to be done. And this is a proposal of many scientists and the direction that the Forest Service is moving. So thinning these dense forests to a low enough level where we can get fire back on the landscape and use fire for landscape scale management. And so probably some, it's hard to say, but maybe, a structure somewhat like this. And the competition would be reduced, and these trees would be more resilient to drought. Okay, so in closing, some of the objectives in my mind is to foster resilient adaptive ecosystems to mitigate climate change. And this is actually a statement, one of the core statements from the U.S. Forest Service moving into the next 10 years. This is what we are striving to do. The way that we can do it in this particular situation, I think, is to restore the natural fire regime and to try to reduce the density of some of these forests. I also think that we shouldn't underestimate the application of science. So we have much of the mortality that's happening is low elevational bands, so about 5,000 to 6,000 feet. And if we can understand how that mortality is happening and what the long-term consequences are, and whether or not some of this forest thinning and returning the natural fire regime is effective in the low elevational bands, we can apply that to 6,000 feet and above, where currently we're not seeing much bark beetle mortality. But it will get there. If we continue to have a warming climate, we will start to see these mortality events marching uphill, and we want to try to avoid that. Education. As I already mentioned, there's been a lot of pushback when we try to talk about forest thinning and putting fire back on the landscape. And so I think that if people understood what the end goal was and the long-term vision, and that we think this may be one of the only ways to keep these forests alive, that people may change their mind. Also, some responsible land planning. I know that there was a land planner in here earlier, so part of me is like, ooh, I don't know if I should say this, but the building of communities out into the wildlands is really a problem. It makes fire suppression almost impossible, and it also makes putting fire back on the landscape very, very challenging. And so some thoughtful land planning would be very helpful. And then lastly, we need to embrace a changing environment. When I wrote that, I was like, ooh, does that mean we just sit back with our feet up and be complacent? And that's not what I intended with the statement, but I think we need to carefully decide how we move forward, and not just resist these changes, but try to be creative and find creative solutions for the changes. And as I was reading and preparing for this talk, I came across two quotes that I thought were interesting. These are from lead scientists in California, one from the Park Service and one from USGS. And the first one said, "The world has changed." This is in regard to bark beetle mortality. "The world has changed. We're never going to be able to get back to where we were before." Okay, so in my mind, that's saying we can't dig our heels in. We need to get in front of the problem. We need to understand the problem. We need to be proactive. We need to be creative. The other person said, "I'm not happy these trees are dead," but this is a classic scientist right here. "I'm not happy these trees are dead, but it's fascinating." And when and when this mortality is done, there's going to be a process where new things come in, and we don't know what. It's the beginning of something new. And so if we can start to foster that process and think about how we can help that process along, I think we'll be in the best shape possible. Okay, thank you. Yes.
How does species diversity or lack thereof
Does species diversity or lack of species diversity play into the patterns of beetle mortality? So yes, the bark beetles themselves tend to have host specificity. And you may have noticed that one of the bark beetle names was Jeffrey pine beetle. So when we have stands of conifer trees that are monocultures, the same species for acres and acres and acres, if that one beetle type gets started in there, it will devastate the entire stand. So in stands that have a higher diversity, we do see some conifers that aren't targeted by that particular species of bark beetle that's going bonkers in that part of the landscape. We do see them hanging on. So you do still have green trees, which can provide wildlife habitat, and yeah, so those high diversity stands appear to be somewhat more resilient. Yes?
Very nice presentation.
People talk about vegetation oftentimes, now that climate change is at the forefront of so many people's minds, thinking about vegetation as carbon storage creatures, right? So plants are able to photosynthesize. They draw carbon dioxide, which is a primary greenhouse gas causing global warming. They draw that down from the atmosphere. Through photosynthesis, they convert it into sugars and carbon, and they store it in their bodies and in their roots. And so as we have this massive bark beetle die-off, people are concerned about, oh my gosh, we're losing so much carbon, we're losing so much above ground biomass. But a huge amount of the carbon is actually stored in the roots of the plants. And so that dies with the above ground portion of the plant and will be turning over. So that carbon, as microbes in the soil and fungus start to eat away at those dead roots, that will be let off as more carbon dioxide. The other issue too, besides carbon storage, when we start to lose above ground vegetation and the below ground counterparts, we start to see that soils become more erosive. And so if we have some big high intensity rain events, which some climate change scientists have proposed that we will be seeing, even if rainfall amounts don't change, that the way it's delivered, that may change, and we may have fewer, more intense rainfall events. And under those sorts of conditions, if there's not soil, if there's not roots in the soil to hold that soil in place, we could have some massive erosion either into communities or in some cases just into streams and creeks and places that it would have a major impact on wildlife. Yes. I haven't interfaced with the foresters, at least on the Angeles, too much, but they do have calls and seminars that they attend that cover many of these topics. And when I can, one of my primary jobs is to try to make my way across Southern California and have these kinds of discussions with people, like the foresters, for example. So there are avenues for this information to trickle down. Whether or not it has happened, I can't say. Yeah.
So it's basically up to the individual.
Right. So those decisions are happening on a forest level and oftentimes on a district level. With any proposal to do that would trigger NEPA. So we would have to put together a report talking about the negative and positive impacts from doing that kind of thinning, and then it would be available for public comment. So it wouldn't, it's not as simple as the forester saying, let's do this. This seems like the thing to do. Let's get on the ground and clear out some forests. There is kind of a longer term painful, in my opinion, because I don't work with NEPA, a painful process that backs that up. But it's a good check and balance for the forest. So the public would be able to comment on those. And in some of the projects that have been proposed, I will say that the public comment has been incredibly negative and has wound up, in some cases, in litigation to stop the projects. Yeah.
You've talked a lot about mechanical.
So the question is, the proposal to undertake mechanical thinning before fire is reintroduced into the landscape is labor intensive, and what does that look like on the ground, essentially, and what kind of planning and resources go into that? So at this point, the projects that I have seen in Southern California have focused on thinning of certain size classes of trees. So they'll say, okay, we have big trees, we have medium trees, we have small trees, and we are proposing to remove 75% of the small trees and maybe 10% of the medium trees and leave all the big trees. So the proposals are binned into tree size classes. That information then is given to the people on the ground. I'll talk about who those people are in just a second, but it's given to the people on the ground, and they go out with their DBH tapes and say, oh, this is a small tree, I'm gonna remove it. Or this is a medium or a large tree, that needs to stay in place. So currently, the people who are doing some of this thinning, there's a whole lot of contractors going out and providing these services. In some cases, too, we do have the fire staff in their off-season. The Forest Service has a huge firefighting component, and I think it's well over 50% of our employees are firefighters. And during the downtime, so let's say November to May, they are out there helping with this process. I did read something the other day. The Colorado Rockies and parts of Arizona are also dealing with these issues, and they have begun to partner up with the Nature Conservancy to figure out an automated way for people to go, for contractors who are going in to remove smaller trees, to go in and actually have a roadmap of the forest and to know exactly which trees are to be removed. So technology is starting to be folded into this issue, but that's all in the trial stages right now. Yes?
Are companies that do,
So the question is, lumber companies who are doing reforestation, what kinds of things are they thinking about right now? Are they planting at the historical densities, or are they starting to scale back? What I have heard from some of the foresters is that there's been a huge discussion about how forest planting should move forward. And so some of those historical planting densities have been scaled back. There's also discussion of like novel planting architectures. So instead of just going out and planting rows of trees really densely, maybe we can plant islands of trees, and through time, those islands will seed out into the areas that have died off or that have been logged in some cases. So yeah, that discussion is happening. The extent to which it's translating to boots on the ground, I'm not certain. Oh, yes. So the question is there discussion in Sacramento about trying to get mills in locations where there's mass mortality? Part of the governor's task force is focused on developing markets, and I'm sure that has been one of the conversations. In general, the development of mills in Southern California, for example, probably isn't something that would ever happen because we don't have a lot of timber resources to begin with, and following the clearing of these dead trees, we want to keep our other trees in place. We want to keep our other big trees. We don't want them to be lost to lumber. And so, in general, I feel like the sentiment has been that the timber industry has been slowly declining in the state, and this has provided this opportunity for some of that to get started back up again. But the question is it sustainable? So in the long term, 20 years from now, is there still gonna be product for them to be harvesting off the forest? And I just don't know. So I haven't heard of any new mills opening or being proposed to be open at this point. Yes?
So,
Actually, there has been some niche markets opening up for the blue stained wood. People are making cute little blue iPhone cases from repurposed bark beetle, trees, and people are starting to use it as flooring. This is very much in kind of yuppie communities are really getting pretty excited about this stuff. And there is no real risk of the bark beetle spreading because the bark beetle life cycle, once those grubs or babies are ready to pupate and form sort of like their cocoon and become beetles and fly away, they don't stay in the wood. They do their business and they're off to the next tree. And so the trees that have been killed the bark beetles are long gone by the time we even see the symptoms of mortality. So the beetles do their thing, and we usually see mortality starting at the top of the canopy. We see little dead brown tips, and the beetles have been probably gone for months at that point.
We know that they are spread by carrying firewood.
Oh, well, yes, so that's the gold-spotted oak borer. So that is a different creature, and that creature is specific to oaks. And in that case, those beetles will stay in the wood even after the tree is dead. So but bark beetles behave differently. Yeah. Yes.
When I hear you say that,
So the question was, has this cycle, it's probably likely to have happened in the past at some point, and do we expect maybe that if humans don't do anything that it could return on its own? I think, did I capture that okay? So the current thinking is that bark beetle, because they are a feature of our landscape, that they have always been able to take out dead or stressed trees, but that the scale of that stress has never been what it is today. So you might have some drier pockets or maybe some dips in precipitation in the past, like in the 70s, there was a couple of years of drought, and you may see some localized pockets of die-off, but never to the scale that we're seeing today. In terms of vegetation recovering after the bark beetle mortality, in many of the stands we don't see 100% mortality, and we're trying to understand right now why some individuals are not hit by the bark beetles, because those individuals are going to be very, very important for the recovery of that forest, because they're going to provide the seeds for new trees to come up. So there's some genetic work that's going on to look at what's special about those individuals, or maybe they were just growing in the right site. Maybe they had more access to water than their neighbors did. The scary part, I think, for most scientists at this point is that if these kinds of events did happen in the past, they were likely followed by years of high rainfall. And so as we look towards the future, there's a lot of questions about whether or not we're going to have that again. We do have it this year, but will we have it next year and the year after and the year after? And so even if we have some individual trees that are persisting on the landscape that can drop a seed and that seed starts to grow into a little tree, they may succumb to death via mortality because there's just not enough rain. Yeah, but that's a good question. Thank you, everyone. Thank you for your time.